One is this one. Myself as Olenjolai, I don't know everything about advanced chemistry. I just know a little, but I'm ready to transfer that knowledge to you. So join with me. So the subtopic, the subtopic of the day is called the mass. What am I going to teach you is mass spectroscopy. This is the contents of lecture 1 and lecture 2. Okay, because in lecture 1 I will teach you the concepts and even the drawings of this mass spectroscope, and then lecture 2 will do the competition, or yes, we'll be solving problems. In some of the books we call it mass spectrometry. Mass spectrometry. Some of the devices we call it mass spectrometry. Say it, mass spectrometry or mass spectroscope. So we have now. So let us start the session. So the first question we have to ask ourselves: what is mass? What is mass spectroscope or spectrometry? What is mass spectrometry? That's the first question. So according to the finding, mass, this is capital, mass spectrometry, we say that is the analytical laboratory, right? Is analytical laboratory technique, analytical laboratory technique used to identify composition of a substance, composition of the substance by their mass. Mass. These are the definitions of mass spectrometry. Say it again. Mass spectroscopy or mass spectrometry. Don't feel shy. Pronounce these words. They are very important in your life. Mass spectrometry is an analytical laboratory. That's the first keyword. Analytical laboratory technique used to do what? To identify what? Composition of what? Substance by what? By their masses. So use mass to determine the composition of the substance. How? Stay connected. Stay tuned. I will tell you how. So that's the first terminology. And this part is just the introductions, but that's the first terminology that we have to learn. The second terminology, this is number 1. That's number 2. The second terminology, which is very important, we call it mass spectrometer. Mass spectrometer. Say with me. Mass spectrometer. Say it again. Mass spectrometer. Say with passion. Mass spectrometer. What is this? Mass spectrometry. What is this? Mass spectrometer. There are 2 different words. So, the second question that we have to ask ourselves is this: what is mass spectrometer. What is mass spectrometer? Mass spectrometer. Mass spectrometer is an instrument This was not an instrument. This is the technique. This is the technique. This is an instrument. Okay, which can measure primary, which can measure the masses, right? The masses, which can measure the masses and relative concentrations of atoms and the molecules. Atoms and molecules. So mass spectrometer is an instrument. Number one, that's a piece of information. Mass spectrometer is an instrument. Mass spectroscopy or mass spectrometry is a technique. Distinguish them. So this is an instrument which can measure the masses. With this instrument we can measure the masses of the atom, and also we can measure the relative concentration of atoms and molecules. Is it interesting? You can find some other definitions or different ways of defining the mass spectrometer, but these are some of them, right? Or this is the one which is very important. And then we say that this mass spectrometer, the mass spectrometer is used to determine the atomic mass, okay, the atomic mass, and to detect the presence of isotopes. Interesting. You used to study isotopes, but you didn't know how to detect it, or how the chemists find them, how the chemists maybe determine that maybe the isotopes of carbon, okay, abundance, or isotopes of chlorine. How did they know? So now in general chemistry, I will teach you step to step, and then you'll find how we used to say that chlorine has 3 isotopes, right? Maybe chlorine has 3 isotopes. Carbon has 2 isotopes, carbon 14, carbon 12, etc., etc. So you'll be learning step by step. So stay tuned. The spectrometer, or the mass spectrometer, got here, the mass spectrometer, because this is specified at which spectrometer, is used to determine the atomic mass, number one. So determines the atomic mass, this is number one. And also to detect the presence of isotopes, this is number 2 application. And then the abundance. And abundance means percentage, their composition, this is number 3. Right? Very interesting. So it means that number 1 used it to determine certain atomic mass. Number 2 used also determines the presence detect the presence of what? Presence of isotopes. And then number 3 used also determines what? Abundance. Abundance of what? Of the atom or molecule. Interesting. soon you are approaching to be a king of mass spectrometer, or a king or a queen mass spectrometer. And I believe that you'll be solving problems of mass spectrometer in a different way. So again, we say that this in chemistry, in order for a chemistry to understand the concept of mass spectrometer, then he has to study the following parts, following 6 parts. Right? The first part you have to study, we call it ionization. Ionization. The second one, or the first ionization, but the second one we call it vaporization. Ionization, this we call it ionization, and the ionization and vaporization. However, the process of vaporization has to start. Okay, so 5, there are only 5 parts important. Number 2, you have also, I have to teach you about acceleration of the atom in the mass spectrometer. The third part, also I have to teach you about the part known as deflection. The fourth part, which I have to teach you, we call it detection. Now we detect the atoms, the isotopes, detection. And then the fifth part, we call it recording. And the 6th part, recording. So these words must be memorized in the sequence. So these parts are listed in the sequence from the first part to the last part of mass spectrometer. Is it interesting? Yes. So then now, the next part of mass spectroscopic or spectroscope, I want now to draw a diagram of 14 of mass spectrometer. So we say that to understand the principle used by the spectrometer, perform its activities or its measurement of mass abundances and the detection of what? Of isotopes. Then a diagram of mass spectrometer must be used. So for you to understand how the principle of working of mass spectrometer is not enough. It's tough, first of all, to learn by reading those descriptions or those explanations. The best way, we have to draw a diagram of mass spectrometer, and then we explain its principle and how does it work. Okay? So join me in the sketch of this mass spectrometer. I'll be trying myself, but you can even look online. You can use the references online or in different sources to see even in color. For me, just I'll be drawn by using the black and white. For you, you can even refer the colored spectrometer. Okay. You can also go to your school lab and ask your teacher to show you the mass spectrometer. It's your right. Okay? So again, here we have a plate, and here again we have another plate. Here we have this is accelerating part. Okay? We'll explain what does it mean. And then from this point, we have a very important part, which we call the deflection region. So here we have a heating filament. Filament. And then this point. You have vacuum pump, the spectrometry routine at this point. Then we have again another part here. Then we have the output at this point. It goes to another section. And then the output of this section, and this one we call it the amplifier. This goes to another section. We call it the chart recorder. Very important part. This is the recording section. So this point, we call it deflection. And then this one, called the vacuum pump. vacuum pump. This section, we can even share. So it has a shadow. So this section, when you say this section, both this and this, we call that section is deflection. Deflection ring. But what does it do, this deflection? This is a magnet. And this section, this one, with this ray, we call it the acceleration section. This is part 2, the second part that I have mentioned there, acceleration. And then this section, this point here, this one, this we call it ionization. Ionization chamber. Here we have another part we call it vaporize the sample. Vaporize the sample. Then this one we call it heat source, or source of heat. Source of heat. So that one's vaporize sample. Here's to vacuum. Then this is figure 1. We call it mass. Mass spectrometer. You can call it even figure 1.1 because we'll be having many figures. So figure 1.1. We have 1.2, 1.3, etc., etc. So my dear student, my beloved student, that is a diagram of what mass spectrometer in chemistry. Let's draw it on your hand. Don't take a photo. You have to use your own hands to draw it, like the way I drew it myself. I can use the digital technology. I could take even the photo and show you in place at in front of the camera, and then show that this is a mass spectrometer. Then you'll enjoy and you'll say that, thank you, Sir Olenjolai, but I didn't help you because you didn't see that how you can draw it yourself. So from now you don't have an excuse. If you'll be asked to draw it, you have to draw it. You're a chemist, so you have to like draw it. So this is the figure now of mass spectrometer. One, let me explain to you how does it work, and then we'll go to the details, explanations, or on learning those 5 parts. Okay? Listen carefully. This is the mass spectrometer. And this is the inner part of mass spectrometer, right? Physically, it doesn't mean that we find a device, mass spectrometer like this. This is the inner part, and especially that we used to learn the operation part, right? The chemical or the chemistry operation part. There are some other parts. It can be maybe electrical mass spectrometer or some other spectrometers, right? So what happens? This is the point of interest. Here we have vaporized the sample. What the means of vaporization? Vaporization, we say that is what? Is a physical change. Why not? We say that liquid, or is that maybe you change solid to liquid, liquid to gas. So the destination is found gas, right? So the sample, which you want to measure its mass, you want to determine the number of isotopes of that sample of the atom, and you want to determine its abundance. Is introduced at this entrance point. That's why we call this one vaporize the sample. Then the vaporized sample, as soon as it has been introduced in the mass spectrometer, it will reach the first sections or the first chamber called the ionization chamber. So in the ionization chamber, remember that this is an atom. What's going to happen here? And then a lot of things will happen, but in brief, in this ionization chamber, the vaporized sample is going to be given ionization NH, If the sample has to lose 1 electrons, then it will be given as the first ionization energy, as well as I will teach you in energetics or in thermochemistry. If the atom is going to lose, or it has a tendency of losing 3 electrons, right? Losing 3 electrons, or 2, for example, for aluminiums, then it will be given, at this point, it will be given first ionization energy, second ionization energy, and third ionization energy. But if the atom is just sodium, then we need only first ionization energy. If the atom is magnesium, which is period 2, period 3, which actually is 12 elements in the periodic table, then we have to give it the first ionization energy, second ionization energy. So that's the main function of this chamber. After the atom has been ionized, so now we don't have atom anymore, we have an ion. Say an ion. So not an ion, the one that we used to maybe we use in domestic. I don't mean about that. Ion, because sometimes pronunciation is a little bit challenged. I'm not talking about this ion. No, I'm talking about this ion, right? So we have an ion. So what happens? So this ion is still moving or traveling with a very low speed. So what happens? So in mass spectrometer, we need these ions to be accelerated, to move. It means to move with a very high speed. So what happens? So we as the chemists, we're against that we make another chamber known as acceleration chamber. So the main function of acceleration chamber is to accelerate an ion which has been ionized in ionization chamber, right? So when you accelerated, that ion now will reach to this point, to this part, which is called deflection point, and this we call the deflection field in some of the books. Okay, we call deflections, or we call deflection field in some of the deflection field. So be familiar about that. Then when it reaches a deflection field, what happening here? Remember that at this point now, because now it means that this sample has been vaporized at this point. So these dotted lines is the trajectory, say trajectory of 40 of this vaporized atom, and then at this point now, we see the isotopes now of 40 of atom. Okay, so this now, it has been moving linearly. So remember that this atom, it has been moving linearly in a straight line. So when it reaches in this radius of 40, you can even just add this magnetic field, you can extend it, okay, so that you can understand the concept, okay? So when it reaches at this point, what happens? This magnetic field, this is magnet, so magnet 1, magnet 2, these are the magnets. So when it reaches at this point, then these magnets will start deflecting. Instead of, because remember here, if we consider the trajectories are the vector, this is the vector, means these the directions of what of electrons. So it reaches here because this ion is actually is electric charge, or is electrical ions. It will be deflected by this magnet. When it will be deflected now, remember that it is highly accelerated elements, then it reaches at this point and then start forming isotopes. So for this element, for example, if you have first line, second line, third lines, it means there are 3 isotopes. So here it determines isotopes, it determines abundance, then it determines its atomic mass. So again, the journey continues, reach at this point at the vacuum pump, also it has something else to add on that, and then now the ions reaches to the deflection, so detection. Sorry, this is not deflection, make correction please. I wrote, could even ask me, this is detection unit, right? So correct it please. Yes, detection unit. So then here we detect the number of isotopes, we detect the abundance, we detect the mass of an atom, and then we'll see how does it operate, because we have computations, we have mathematical, and we have problems. And then the output of this sample, so this is still the output of detection region or detection unit will be sent to the amplifier. Say amplifier. Amplifier is very important part in analog electronics. I like electronics a lot. I'm an electronics engineer, as I can tell you. I used to learn a lot about amplifier, and they are doing a big business actually that in the world of electronics of today. So here it means that the ions will be amplified. Means that what the means of amplification? It means that changing its magnitude from the small magnitude to the large magnitude by using what the amplification factor, which we call total gain. It might be current gains or voltage gain. And then here we have total recorder. So this is the recording sections, because we say recording section, the last part. So here the point that we used to record, and here this is the point where we used to find out a display which will be showing the lines of the isotopes which will lens in near future. And then that's how now we have that's how the mass spectrometer measure, or that's how the mass spectrometer operate. Okay? So in the next few minutes I will be explaining this part, how does it work, this part, and even this part. So I've just given you an introduction. I'll be explaining and writing some sentences for you to review them. So after we've discussed this, remember that one thing that I want to tell you, and even myself I find when I was in high school 11 years ago or 12 years ago, this is a common question for the midterm test for those pre-form 5, and even the final exam in some of the years that I used to give you 10 marks to draw this and explain how does it work. So take care about this. You might remember me maybe one day within a specific time when you are in hot chamber of exam. Then another part that we have to cover, we want to learn in brief principles of 40 mass spectrometer. Principles of mass spectrometer. What are the principles of mass spectrometer? There are 5 principles. So the question is, this is maybe question 3. Yeah. Describe briefly 5 principles of mass spectrometer. The first principle is this. We say that the substance, it means atom, not the ion, the substance to be analyzed. Substance to be analyzed is firstly vaporized. It's firstly vaporized, right? And it is then it is introduced in the ionization chamber. The ionization chamber, where a metal filament is heated strongly to produce enough energy to cause ionization. Cause ionization to occur. occur, that is positive ions, are formed. The first principle states that the substance, for example, magnesium, aluminium, sodium, lithium, right, carbon, the substance to be analyzed, that we want to analyze, we want to measure its atomic mass, we want to detect the number of isotopes, we want again to know its abundance, is first vaporized. What it means of vaporization, as I told you, if it is in solid state, vaporization reactions with the given atomization energy will be given to that metal, and then to be changed from the solid state to the gaseous state. So what we used to introduce the mass spectrometer should be in gaseous state. Remember that. And then it is introduced into the ionization chamber. So this ionization chamber, as I told you, ionization chamber. So then where a metal filament, so this is very important again, a metal filament, where the metal filament, this one, this is metal filament. A metal filament is heated strongly. So this metal filament is heated strongly. So we have a filament here. Okay, we have a filament. So metal filament is this one. Is heated strongly, right? It's heated strongly. Metal filament is heated strongly. Metal filament is heated strongly to produce what? Enough energy to cause what? Ionization to occur, and that is the positive ions are formed. So we used to form positive what? Ions. Means electrons. Ionization means that it is a process whereby an electrons, or whereby 1 mole of an atom is what? 1 mole of an atom is losing 1 electrons to form what? 1 mole of what? Mono positive ion, if it's first ionization energy. But from 1 atom of what? 1 atom of positive ion. No, 1 mole of positive ion. By the means of what? Ionization energy. The second principle is this. The positive ion ions produced in the ionization chamber. Ionization chamber are accelerated now by the negatively charged particle, negatively charged plates. So the positive ions produced in the ionization chamber accelerated by the negatively charged plates. Where are the negative charged plates? This one. Okay? So these are the negatively, so this is negatively charged. So this is negative, negative, negative. This is also negative, negative, negative. Charged what? Particles. Okay. So the third principle, we said that the positive ions produced are then then deflected. So we say about accelerated, it's better if you bold it. So let us bold this way the acceleration or accelerated. So here are deflected. 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 Okay? Are deflected by the magnetic field. By the magnetic field according to the so remember that these are the principles of working. Principles of working of mass spectrometer. You see it? Let me illustrate it clearly. That's very important to read. This is how the mass spectrometer works. Principles of working of mass spectrometer. So describe briefly 5 principles of working. 5 working principles. 5 working principles of mass spectrometer. Or sometimes in some of the books, how, you can ask you a question, how does mass spectrometer work? Explain how does mass spectrometer work. So this is the description. So the positive ions from the acceleration chamber produced are then deflected. By the magnetic field. By the magnetic field according to the mass. These deflections depends on what according to the mass. Okay, mass to charge ratio. Mass to charge ratio. Mass to charge ratio means mass over Z. So that ions with greater value of ratio are deflected less. I don't want to rub here. Please make sure that you copy that section. I want to leave this because I want to use it for explanation. But let me just explain this the principle. The positive ions from what? Acceleration chamber, where we have negative plates, are deflected by the magnetic field here. This is the positive ions deflected by the magnetic field according to the mass to charge ratio. Mass to charge ratio. So this is the point where it has the mass to charge ratio. So listen, what happened? An isotope which will have a large mass, a large ratio of mass to charge ratio, will be less deflected, right? Principle which I have explained here, that the substance to be analyzed is first vaporized and it is introduced in the ionization chamber, where a metal filament is heated strongly to produce enough energy to cause ionizations to occur, that is positive ions are formed. It is the place where the ionization process is taking place. And the second principle, that is the positive ions produced are accelerated by the negative charged plates. So it means that are the negative plates, these three are negative plates, which are used to accelerate the produce the ions in the first chamber or in the ionization chamber. And then the third principle states that the positive ions produced are then deflected by the magnetic field according to the mass to the charge ratio. This is the point. This is the chamber that the third principle is explaining. These are the magnets, at the above magnets, and we call it deflection chamber or deflection regions, whereby the ions now it has been ionized, and it's high speedy ions that moving or being accelerated by this negatively charged plates. Okay, so in this deflection chamber, what happens actually? We have different. Remember that some of the elements contains isotopes. So what happens at this point? So at this point, we say that according to the mass to the charge ratio, it means that the ions which will have a less mass, it means that less mass to charge ratio, and then still be highly deflected, while the ions which have the greater mass to the charge ratio will be less deflected, and the one that have intermediate between the highest or between the largest and the smallest tend to be medium deflected, as it has been shown here. So let me take you to the first principle. Before we go to the first principle, I want just to explain you in details about the second principle. Okay, the second principle. So in the second principle, you say that ions that will have a high mass to the charge ratio will be less deflected, while ions which are less mass to the charge ratio will be highly deflected. So let us write that sentence. So we say that the ions, say with me, the ions, okay, the ions with greater value of the ratio of mass to charge ratio, in bracket mass over charge, can are deflected less, while ions with a smaller ratio are deflected more, while ions with less ratio, less or smaller ratio of the mass to charge, smaller ratio or with less ratio of mass to charge means, okay, will be deflected more. Okay, will be deflected more. So this the demonstrations of this sentence, that we say that at this point this ion has a large mass to the charge ratio, so it is less deflected. Because if it is the one which will be deflected more, will be deflected this way. Because remember that these ions are accelerating in a straight line. So it means that this magnetic field is the one that changing the directions of of movement of these ions. So this is an ion, or this the trespass. We call it stream in chemistry or in mass spectrometer. We call that this the stream 1. For example, that this is stream 1, and then this is, let's say, stream 3. Okay, stream 3, and this is, we call it stream 2. Okay, so this is what happens. So this is highly deflected, less deflected, moderate deflected. I think that you have understood. If you have any questions, please ask in the comment section. So the first principle of working of the mass spectrometer state that the movement of ions, is detected. This now discuss about detection chamber. Is detected to the photographic plate. Detected to the photographic plate by producing a current. Okay, by producing a current, and the current depends on the number of ions produced. This current depends on the number of ions produced. So the first principle discussing about detection chamber, right? You see detection chamber? This is the detection chamber. So in this detection chamber, we have 3 ions. First ion, second ion, third ion. So they'll be detected by the photographic plate. And then after detection, what is going to happen? Then it will produce a current. Remember that currents, it can flow by vibrations or, yes, we call vibrations or movements of electrons. And then even ions also, they can cause an electric current to flow. So this current depends on the number of ions produced. If you have a large number of ions produced, then the currents will be larger. And if you have a less number of ions produced, then the current will be smaller, right? That's how the principle it is. So it means that the main concept here is, remember that here we use, it means that here the chemists used to have a photographic plate in order to detect this what ions that has been deflected by the magnetic field regions. So let us go to the fifth principle working of mass spectrometer. Okay, the fifth principle working of mass spectrometer, and then generalize and see the applications. Remember, the concept of mass spectrometer is broad in chemistry. You can study it as well as you can. You can go in different books. Okay, the result is recorded. Now we are discussing about the results. The result is recorded. We are discussing about what? Recording chamber is recorded in a graphical manner. This is a fantastic principle. In graphical manner, not in tabular manner, but the results will be recorded in graphical manner. Since the mass spectrometer, why? Since the mass spectrometer has been calibrated to give both mass and the intensity. Mass and intensity in 2 dimensions. I will explain in detail about this. The first principle right now is discussing about, because here we have an amplifier, so that's your homework, please. go and look what the functions of an amplifier in the mass spectrometer. Make sure that you read it and you find it's a main purpose. So we say that this is the chart recorder. So we call it a chart recorder because the results are given, results of the mass spectrometer are given in a graphical manner. Why? Because the mass spectrometer is being calibrated to give both mass and intensity in 2 dimensions. What does it mean? The results of the mass spectrometer will be given in a graphical order, whereby, for example, when we say about graphical manner, this is all about, we'll discuss this in detail in lecture 2, relative abundance. So relative abundance, so you say that in relative abundance, the vertical axis will be representing relative abundance, while the horizontal axis will be representing the mass to charge ratio. So if, for example, an element has 3 isotopes, then you will see lines like this one. So this is the first mass to the charge ratio, second mass to the charge ratio, and then this is the first relative abundance, second relative abundance, and then suppose that this is the third relative abundance. So this is the result of the mass spectrometer, and will be displayed in the chart recorder, or are the results that we have to see concerning about what you've been measuring, or the mass and relative abundance of what, because we say that, remember that the mass spectrometer has 3 functions. The first one is used to determine the relative molecular mass of the element, and the second functions that I told you is used to also determine the abundance, okay, and also and the third one is also to use it to make detections of the number of isotopes that are present in the element. Not every element has isotopes. Some of them they do have, and then the mass spectrometer is the one that used to make a distinction about the elements that have isotopes and elements that don't have isotopes. So you have to make sure that you understand about that. And I again remember that the mass spectrometer also it is used to measure the mass, or determines or perform those 3 functions for the elements, and also to use it for the molecules like chlorine molecules or oxygen molecules. Not only that, but also mass spectrometer can identify those 3 parameters to the compound. Fantastic, right? So it means that the mass spectrometer is broad, depends on area of application that you're interested in. Okay, so that's all about the principle of working of the mass spectrometer I've been discussing with you. And then right now I would like just to take you and discuss in short or in brief the applications or uses of mass spectrometer. Why are we studying mass spectrometer in chemistry? Why this has been a fundamental concept to introduce to the A-level students for the first time. So just join me in a few minutes that I will mention some of the applications of mass spectrometer, and then I'll leave the homework for you and make sure that you go through it, and will be the end of lecture 1. Don't forget to join me in lecture 2, and especially to discuss about the computations now, the problem solving of mass spectrometer, right? And then we'll be reviewing some questions that used to appear in the final exams or in different exams. So stay tuned. And remember that, stay tuned. If you have any question, please don't hesitate yourself to ask in the comment section. I will try my level best to answer. And even some other students in the world can try their level best to answer your question. So remember that you are not alone. We are together, and also you are learning this stuff with thousands of the students in Tanzania and even abroad of Tanzania. So let us go to the uses of applications. Remember that this is not a limitation that this is all about the mass spectrometer, but I've tried my level best to summarize and make sure they give you the concrete issues that you need and according to the syllabus, requirements of the syllabus. Okay? So uses or applications or uses of mass spectrometer. Mass spectrometer. What are the applications of mass spectrometer? That's the question. Okay? So the question you may be asked is, what are the applications of 40 of mass spectrometer? Why are we studying mass spectrometer? So I found 4 applications. You may find even the rest, the 2, your own 4 applications. This doesn't mean that all of these are this the end of applications of the mass spectrometer. There are some other applications. Okay? A mass spectrometer, a mass spectrometry or spectrometer, mass spectrometry can be used to identify, elements from the mass number of isotopes. From the mass number of isotopes. The second applications, we say that the mass spectrometry or mass spectrometer can be used to identify elements from the mass number of 40 of isotopes. That, for example, it can be given a sample of element X. You don't know what the names of that elements, and then you can use the mass spectrometer to identify which elements it is by using the number of isotopes. Okay, because you know that the number of isotopes distinguishes one element from the other element. For example, that we know that for instance, chlorine has only 2 isotopes. Okay, so that is, so you say that mass spectrometer can be used to identify elements from the mass of the isotopes, and then we'll discuss it in detail later. The second application says that a mass spectrometer through mass spectrometry, which I will teach you, through mass spectrum, I'll teach you in lecture 2 what the means of mass spectrum can be used. This is the fundamental applications of 40 of mass spectrometer for A-level students. Can be used to calculate the relative atomic mass of the element. That the second applications or of the elements of an element. The third applications, we say that the mass spectrometer through the mass spectrums can be used to calculate the relative atomic mass RAM of the element. And I will teach you in lecture 2 how we use this mass spectrometer to do that. Again, mass spectrometer can be used to determine the relative molecular mass of a compound. The mass spectrometer, this mass spectrometer can be used to determine the relative molecular mass of the compound. Okay. Then the fourth application first application first applications of mass spectrometer is this. The first application, you say that the mass spectrometer through mass spectrum again, which I will teach you, is used or can be used to find the relative abundance of isotopes. Relative abundance of the isotopes. The specialized use of mass spectrometer to determine the relative abundance of isotopes is given, or in a given sample, is known as isotope ratio mass spectrometry. Okay? Isotope mass spectrometry. So he said the mass spectrometer through the mass spectrums can be used to find the relative abundance of the isotopes. What does it mean? This means that when we have the results of mass spectrometer, this, remember that I told you that it represents relative abundance, and then this is mass to the charge ratio. So, but the mass spectrometer also through the mass spectrum, this is what we call the mass spectrum. For example, we have two isotopes, so isotope 1, isotope 2, can be used to find the relative abundance of 40 of the isotopes. So, and then so we learn in lecture 2 in details about relative abundance and this mass to the charge ratio. I would like just to say that let me just leave the homework for you, okay, the homework that you have to do before lecture 2, and this the question that, okay, explain briefly the meaning of the word mass to isotope ratio mass spectrometry. Isotope ratio mass spectrometry, in abbreviation called IRMS. This is the homework, and then make sure that you do this homework, and in case that you find some troubles, join me in lecture 2 when I will be starting these corrections, but depends on the finding that I will see in the comment sections. If everything is okay, then I will move to the concept of the lecture 2. And then I would like just to say that this is the end of lecture 1. Thank you very much for watching. This is Olenjolai Moko Tayailo Singo from Tanzania, and I would like just to thank you for joining me in lecture 1 of the atomic structure, or the main topic is called general chemistry, and the topic is the atomic structure, and then the subtopic is mass spectrometer. Make sure that you join me in the second lecture of the mass spectrometer, when we're doing the computations and learns a lot about the results of the mass spectrometer. Okay, thank you very much again and again. I would like just to ask you that make sure that you subscribe onto this channel, and then make sure that you share with your colleagues, and ask any questions in the comment sections as well as you can. But make sure that you go through this material, and before you go before you go to lecture 2, lecture 3, lecture 4, make sure that you start from the beginning. Thank you very much. See you in the next lecture. May God bless you. I love you.